All right, now we're going to talk about piecewise functions in calculus. So hopefully this doesn't get too long, but there's a lot of little things that we have to watch out for here. So let me get me out of there. So here's a piecewise function. It has 4 pieces, and we have some questions. The first one's not a calculus question, but the last few are. So very basics of it. The first thing is asking what is f of -1. So f of -1, you have to figure out where the piece exists at -1, and it's, let's see, it would be this piece right here, because this second piece is the one that exists between -2 and 0, which is where -1 is. So f of -1 is -1 quantity cubed, which is -1. That's pretty simple. Next one quickly, f of -2, you have to figure out what piece does -2 exist at, and it turns out to be the same piece because of that or equals to right here. So f of -2 is -2 cubed, which is -8. So that's pretty basic. Say they wanted to ask you what f of 1 was. F of 1 would be on this piece. So you would plug in 1 to x to the 4th plus 5x minus 1. And that will include answers printed out if you want to look back. So number 2 is determining which values of x for which this function is discontinuous. So it's very simple to say it's discontinuous when these pieces don't match. And then you can come up with the answers pretty quickly. But you have to be careful here because this is going to be a free response exam. And just saying they don't match is not a good calculus explanation. A function is continuous when the limit exists and the value of the function is equal to that limit. So you have to go in terms of limits here. So we're going to start at x equals -2 because that's the first possibility that there's a discontinuity, because that's where the first part of the function stops and the second part takes over. So we're going to test x equals -2. First, we're going to figure out if the limit exists. So the limit to exist, it had to be the same from the left of -2 as it is from the right of -2. So you have to calculate those two one-sided limits and then compare them. So the top one, as x approaches -2 from the left, well, when x is less than 2, that's where you're approaching from the left. So this would equal -2 squared minus 1, which is 4 minus 1, which is 3. Now we're going to go to the limit as x approaches -2 from the right, and this is the piece of the function that exists to the right of 2. So you would plug -2 into the x cubed function, and you'll get -8. Now, since these limits aren't the same, that means the limit as x approaches -2 of this function does not exist, which means it's not continuous, because one of the big things with continuity is the limit must exist. So it's discontinuous at x equals -2. So you would go now back and check 0 and 1 as well. I'm going to do 1 just because it's going to come up with a different result. So at x equals 1, do the same thing. The limit as x approaches 1 from the left, compare that to the limit as x approaches 1 from the right. And make sure you're using these notations. So 1 from the left, you're going to use this function. So this would be 4 times 1 squared plus 1, which is 5. That was that. 1 from the right, you can use this piece, and that's going to be 1 plus 5 minus 1, which equals 5. So the limit does exist. The limit as x approaches 1 is 5. Now, technically, that doesn't mean it's continuous. There's one more thing we have to show. We have to show that the value of the function at 1 is also 5. So you should also write f of 1. And when you look at f of 1, you use this piece, and that's obviously 5. Those two things together tells you that it's continuous at 1. So it's not a discontinuity, but if it said if the question was, is this continuous at x equals 1, this is what you would need to show. So that's that question. The next question is, where is it not differentiable? So I'll quickly tell you how to do this. I don't want to spend too much time on this. You can just look at the solutions. But to figure out where it's not differentiable, you have to figure out where their derivatives match. So basically, you're going to write the derivative of this function, which is f prime of x equals 2x. X is less than -2. It equals 3x squared when x is between -2 and 0, and so on. And so on. Notice, first of all, that I'm not including these equal signs on my derivative because I'm not sure if it's differentiable or not. So to figure out if it's differentiable at -2, we're not going to write this out, but you would plug in -2 to this function, you'll get -4. And plug -2 into this function, you'll get 12. Since the derivatives don't exist from the left and the right, it's not differentiable. If their derivatives were the same from the left and the right, then it is differentiable. Next question, find the average value. That's not going to be a question on the AP exam, remember, this year. So I would ask it like this. Actually, find the integral of this function from -1 to 3. Now, that could be asked. Now, it doesn't matter if it's continuous or not to take the integral. All you're going to do is add up the integral of the pieces. So this would just be the integral from -1 to 0 of that piece, plus the integral from 0 to 1 of that piece, and finally plus the integral from 1 to 3. So you just add up all the intervals, each piece separately, and that will give you the answer. So when you look at the solutions, my answer I'm going to divide by 4, but that's not, you would only do that for the average value. So when you look at my solutions, don't divide by 4. So f prime of x is going to be really this, but only include the equal signs if it's differentiable. One last very important thing. I hope you're hanging with me and watching this whole video. When they ask about differentiability and continuity, remember continuity. Oh, no, let me do it this way. Differentiability implies continuity. If a function's differentiable, then it's continuous. That's a really key concept in calculus. But the contrapositive must be true as well. So we know if it's not continuous, then it's not differentiable. That wasn't true for integration, as you can see. It's true for differentiability. So when they ask you about differentiability, if you can see up here, there's a spot where it's not continuous. Like we said it wasn't continuous at -2, then you can be assured that it's not differentiable at negative. So hopefully that makes sense. Please let me know if you have any questions. I'm going to also include a worksheet and answers so you can practice this.